Vision builds the world out of light. Hearing builds it out of something even more invisible, vibrating air. Let's follow that vibration from a slammed door to the meaning in your mind. Sound is pressure waves traveling through the air, and two features of those waves become two features of what you hear. The frequency of the wave, how fast it vibrates, becomes pitch. Fast vibrations sound high, slow ones sound low. The amplitude, how big the wave is, becomes loudness, which we measure in decibels. So pitch and loudness, the basic dimensions of hearing, are just frequency and amplitude translated by your brain. Now the journey. Sound waves funnel into the ear and strike the eardrum, setting it vibrating. Those vibrations pass through three tiny bones in the middle ear, the smallest bones in your body, which amplify the motion and pass it to the cochlea, a coiled, fluid-filled structure in the inner ear. This is where transduction happens. Inside the cochlea, the moving fluid bends tiny hair cells, and the bending of those hair cells generates the neural signal that becomes sound. From there, the auditory nerve carries the message to the temporal lobes on the sides of the brain for processing. Those hair cells are precious and fragile, and crucially, they don't regenerate. Loud sounds physically damage them, and once they're gone, they're gone. That's the biology behind noise-induced hearing loss, and it's why a lifetime of loud concerts or earbuds turned up too high adds up to permanent damage. How do we tell a high note from a low one? Again, two complementary mechanisms. Place theory says different pitches stimulate different locations along the cochlea, high pitches near the entrance, low pitches deeper in. Frequency theory says the rate at which neurons fire matches the frequency of the sound itself. Together they cover the full range of human hearing. There's also the elegant trick of locating sound in space. Because your two ears are a few inches apart, a sound coming from your right reaches your right ear a hair sooner and a touch louder than your left. Your brain reads those tiny differences and tells you where the sound came from without you doing a thing. Vision and hearing get most of the attention, but they're only two of your senses. The others, smell, taste, touch, pain, and your hidden sense of body position, are doing constant, underrated work. We turn to them next.